Hello and welcome to today's episode. This is Rawkode Live. I'm your host, Rawkode. Today we're going to be taking a look at Falco, a security runtime for Kubernetes with the magic of eBPF. I don't really know what that means, but fortunately I have two wonderful guests who do. Leo Di Donato and Lorenzo Fontana, two former colleagues of mine at my days from Influx Data, now working as engineers at Sysdig and maintainers of the Falco project. Before we bring them in, I want to thank my employer, Equinix Metal. They provide the time for me to work on this show and produce content to hopefully educate and help us all learn this very vast and complicated cloud-native landscape. If you want to try Equinix Metal yourself, you can use the code RAWCODELIVE. This will get you $50 of compute time. That can get you roughly 100 hours of a 96 gig of RAM machine with 28 cores, or you can splurge it all in 5 hours with hundreds of gigs of RAM, 400 gig of RAM, and 3 terabytes of disk. So, take that $50 and use it wisely or unwisely. That is up to you. Now, I am going to bring in my wonderful guests for today. Hello, Leo. Hello, Lorenzo.
Hey, nice to see you.
There we go. How are you both doing?
So far, so good. We are really into some new things for Falco at the moment, but everything is fine. Aside from the fact that everyone is buried into our houses here in Italy again, as everywhere else in the world.
All right. Well, why don't
I really enjoyed your music, honestly.
Yeah. Like, I don't know. I keep meaning to make a joke about it. Like the intro and the outro are quite energetic, and then there's me, which is like way down here in the energy kind of spectrum. So there's a bit of polarity, but I like it. It's good. So why don't we start with Lorenzo? Do you want to just introduce yourself, and then we'll move over to Leo, and then we'll talk about Falco.
Yeah. Well, I'm Lorenzo Fontana. My nickname is unpronounceable, so I'm not going to pronounce it. Just read it. And I'm working at Sysdig, and Sysdig is sponsorship. Mine and Leonardo works on Falco to be the maintainers of Falco and to help Falco becoming some more stable and adding features, and also with hopefully having it graduated in the CNCF after reaching incubation last year. I'm also the author of Linux Observability with BPF with David Calavera for Riley, if you want to check out that book. And I'm doing a lot of BPF work recently with my friend Leo and with others. And that's it. Leo, it's to you.
Okay, so my name is Leonardo Di Donato. As Lorenzo said, I'm an open source software engineer at Sysdig, where basically our daily job is to code Falco, maintain it, evolve it. So yes, we spend all the day on GitHub, which is something that we love. And basically, you can find me in the webverse with the nickname that I put here, Leodido, over Twitter, over GitHub. My daily duties are very similar to Lorenzo's one. So basically, we're in charge of coding Falco, which is a C++ project, but also to maintain other parts of Falco that makes possible to detect security threats at runtime, namely libsysp, libscap, and drivers of Falco. That at the moment we have like 3 drivers: a kernel module, an eBPF probe one, and a Userspace one based on ptrace, Ackery, Wizardy.
Crazy stuff.
Yeah, I understand some of the words, so we're making progress here. Can we?
We don't even understand them words.
Yeah, you said C++, and I was like, oh dear, like that takes me way back. I haven't written a line of C++ in a long time, although I do keep up with the changes to the language, and it is looking really more impressive these days with some of the newer changes. So, Let's talk about Falco then. What are the primary use cases for Falco? Why should people have Falco running in their cluster?
I go.
Wanna go? Or?
I go. You can compliment. Leo keeps me sane usually. This is one of Leo's duty. Keeping me alive. So Falco is kind of simple, but also somewhat complicated. Basically, you use it to be alerted when something bad happens in your cluster. This is a very basic explanation, very high level explanation. So let's say someone spawns a shell, or someone creates a privileged pod, or someone creates a config map in Kubernetes with some credential that should not be there, like AWS credential or Equinix credential, these kind of things. Someone chmodified that should not be chmod, or someone gets root access to something, or someone manages to get a root shell somewhere where it should not be allowed to. This is all done via a thing that we call Falco rules, and they are just expressed in YAML, because everything is YAML. And so you just write some YAML, and out of that YAML you get some nice alert messages for when something happens. The value of Falco is not just the code that processes the YAML and gives you the alerts, but the community also puts a lot of effort into creating a sane default rule set for the vast majority of the people out there. So you can create your own rules, you can make rules adapt to your organization and your needs, but by default we ship a default rule set which should be good enough for most of the use cases. That's what I had to do.
Can I add a bit?
Yeah, please do.
Basically, just like an introduction, more generic. If we look a way to better position Falco in the security landscape, I mean, if we look at the security landscape, we could simplify it in basically two parts: prevention and detection. Both of the parts have one thing in common, which is policies, which is another cool name that we could give to Falco rules. And the difference is that while prevention tools use those policies to change the behavior of processes by preventing syscalls to happen or stopping processing to execute and things like that, on the other end, the policies detection tools use policies to monitor the behavior and notify a user when the behavior of a process steps outside of the policy. Which means that Falco, differently from other tools like SecComp BPF, AppArmor, Falco position is on the detection side of the security landscape, which does not mean that you should only use Falco or you should only use prevention. Basically, the best approaches in the security is to use a defense in depth, which means stacking different tools with different strategies, some for prevention and some for detection, together to achieve a satisfactory level of security, which, by the way, will not be perfect in any case. So this is where we can position Falco to make clear maybe to the audience that differently from other tools like AppArmor, SecComp, and things like that, it positions on the detection side, especially for cloud-native environments like the Kubernetes-based ones, which is a field that's where security, I mean, should be solved yet. There's only Falco and nothing more to, as far as I know.
All right.
Yeah,
I mean,
we call it container runtime security.
Yep.
Yeah, this makes sense to me then. Like I like the defense in depth. We should be using AppArmor, SecComp, all these things to restrict what our containers can do. But inevitably things can and will go wrong. And Falco is what we use inside of our clusters, or I guess does it need to be in a cluster? Can it just run on Linux?
Yeah, it can also run on. Theoretically, that's the preferred way to run Falco on the host below the cluster.
So we run Falco on our host. It's going to use eBPF and some other drivers. It's going to alert to us when things happen that we want to be aware of. And then from that, we can then react to that. We can then decide how we want to handle that information. Sometimes it might just be, notifications, like someone sudoed or whatever. I don't know what the capabilities are, but we'll look into that shortly. But I get it. That makes sense. All right, let's tackle. We got a couple of comments, so I'll just run through those quickly. So,
there's someone.
So Robin says, you've been enjoying the streams. Thank you very much, Robin. They're going to keep coming because I love the sound of my own voice. Allison is saying, looking forward to learning more about Falco. Me too. Definitely one of those things that seems scary, and I'm hoping that you two are going to make this easy for me to understand. And at Kokoran, bloody YAML, I think we are all, we all have that same
Well,
sentiment.
yeah, we all have that sentiment, but I still prefer YAML to second policies or other things like that.
And also, processing YAML in Go is a thing. Processing YAML in C++ is a different league.
It's a
Oh,
whole
my.
new level.
Just-
I mean, as much as we rant about YAML, I think we all do in the cloud native space because there's so much of it. It's really, I mean, besides the edge cases, it's really easy for people to pick up and learn. Like, you know, there are a lot of benefits as well. We shouldn't maybe be too quick to judge it. But anyway, let's get started. This is going to be interesting because I had some homework to do up front, and I'm hoping I've not messed that up. So, if anyone wants to learn more about Falco after today's session, it is open source. You can go to github.com/falcosecurity/Falco. Today's servers are provided by my employer, Equinix Metal. I have spun up using the cluster API, which is just amazing, my own Kubernetes cluster. And I have some backup resources here that I think I'm going to need when it comes to doing some of the Falco stuff. That was my homework that I have failed to do. Regardless, we do have a running Kubernetes cluster, which should still be running. There's always that moment of fear. But yes, we have a 1.19.2 Kubernetes cluster. We are running Ubuntu 20. Now, there were some prerequisites from you both regarding to what I needed in this cluster. Can we maybe just discuss why we're worried about the operating system version being Ubuntu, why we're worried about the Kubernetes version? What are some of those prereqs?
Very quickly, Falco is very tied to the kernel, right? So we are trying to make the Falco experience to be very good on, most of the kernels, most of the distributions. It's very easy for us to be working very well on newer kernels because you have a couple of options to run Falco. I mean, the real options. We have the new Userspace option, which is still under heavy development, which should be solving the problems that I'm talking about. But the options that you have are essentially the kernel module and the eBPF probe, right? So the eBPF probe runs only on very new kernels, runs well only on very new kernels, and the kernel module runs from kernel like 2.6 to newer kernels. This means that you have to compile a kernel module or compile an eBPF probe because both rely on a stable API from the kernel. So they cannot be compiled once run everywhere yet, right? So you just have to compile for the kernel where you are. The Falco community tries to package Falco in a way that you don't have to worry about that. And the way that we package that is, the usual RPM and deb-based packages. So if you install from those, should install smoothly and you should just work. If you install from a container, like you kubectl apply something where a Falco container is running, like you use our run chart or you use our YAML definitions, it will use a Falco Docker image, Falco container image, that will need to figure out the kernel and compile the kernel module or the BPF Pro for you, right?
Okay.
If it can't, we have a web server where we host thousands of compiled kernel module and BPF probes for thousands of different kernel combinations. So we are trying.
You can go to download.falco.org to count all the pre-built drivers.
And this is just click driver and a version 2A is the latest. So this is very useful. But what happens is that for common operating systems, we pay more attention to it. Like for Ubuntu 20, for newest Fedoras, for CentOS, for very widely used operating systems. We did a survey, and it turned out that people use Ubuntu, Fedora, CentOS,
Amazon Linux.
A lot of Amazon Linux is probably our most used image. and the others. So we try to keep up with that. We have a lot of YAML. Every one of them is a YAML file. So yeah, more YAMLs for the comments. So if you want to compile, if you want us to provide a precompiled for your specific combination, you open a pull request with a YAML file, and our build system keeps that, takes it, and compile the Falco driver for that one.
The kernel module or the BPF probe or both?
Yeah, the kernel module. It depends on if it can. And it puts it on this downloads repository. So we are trying to, make sure, but for this demo, because, the demo gods are not always good, we just said, Ubuntu 20 should work. Maybe it doesn't, but sure.
We'll see.
Okay, so to summarize that, it wasn't actually a prerequisite. It was just to simplify things for today's session. If you want to use other operating systems, it's always an option. You just may have to compile the driver and stuff yourself. That's it. Right? Okay. Yeah. I think I get that. That makes sense. So let's...
That's the last resort we want you to have. But hopefully,
I'm sure
people
things are on our side.
That.
Yeah. It'll be fine. Okay. So should I pull up the docs? That would probably be the first step, right?
Exactly. Yes.
All right. So we have a Kubernetes cluster. I have access to all of the machines. So I'm assuming you mentioned earlier that we're going to apt-get install Falco. That's kind of what I'm seeing here too. So am I just going to go ahead and add this repository, right?
Yeah, we have two, as I said, we have two ways of installing Falco. Maybe, Leo, you want to give a reason why we are suggesting apt?
Well, this way we'll install Falco on the host. It's not clear to me if we want to install Falco on the host, which is the recommended way, or if we want to install it with something like Helm charts. I would go with apt because the experience is way cleaner in my opinion, and also architecturally that's the place where the Falco should be, in the host.
Yeah.
Otherwise,
sorry. It's very what Leo wants to say, maybe I'm just saying it for him, is that Falco is a very foundational component in an infrastructure because it actually makes sure that nothing happens in the host. Right. We are also doing steps to make sure that Falco boots as fast as possible in a system, like even maybe, if possible, like exactly when the kernel boots at some point, because Falco needs to see everything. I mean, if someone put a rootkit in your initRD, you're not going to have Kubernetes booted up in your initRD, right? So, for example, we are, encouraging users to always deploy Falco at the same level they deploy, their other machine component that they use for, like the kubelet or the CNI plugins. I mean, at the same level, so that Falco can take over and understand everything that's happening. You can still deploy Falco in Kubernetes right now. It doesn't have any differences in features, but in the future we want to make sure that Falco takes over more components. So we are suggesting that. Also, if you install Falco in Kubernetes, that means that if someone accesses your Kubernetes cluster, unauthorizedly, they can stop Falco, like immediately from every node that you have. And that's not good because Falco is there for.
Or worse, they can leave it running, but removing rules. So you will not notice. You will, okay, everything is fine. Falco is not triggering any rule, any alert. And that's because they disabled the rules at all. So that's
even worse. I agree.
Yeah, this makes sense. Kubernetes is great. Containers are great for most workloads. But if we're integrating and talking to the kernel, we're providing security concerns. Like running this on the host seems to me like it should be the right way forward. So, let's.
And also, not many people want to run a privileged container in a cluster, and Falco will be one because it has no other way. So.
Broadcast, so that should.
Yeah.
I know this is going to be a pain for people to read, but all I'm doing is copy and pasting the command. So we've added our Falco repository. We need the Linux headers because we're compiling a kernel module or installing a kernel module, I would imagine. And then we install Falco. And that should be it.
You're really mastering this science, David.
Yeah, I always start off strong and it goes down fast. Don't worry. Like, so that's it. Okay, this is just other distributions. So, does the Ubuntu package do the driver installation, or do I still need to run through these steps here?
It should be already done. You can check that out with lsmod pipe grep Falco.
All right, so mod probe Falco.
Oh, wait, you probably didn't do apt install Falco.
I did.
Oh, yes. It's there. Okay.
I just had to mod probe it, and all of the machines now have Falco returning on ls mods.
Yeah.
But I think that's a win.
If you just systemctl start Falco, it will have done the mod probe for you.
Ah.
Yeah, just we didn't start it.
Of course, systemd, all the things. I always forget. Okay. So that
Let's verify. Okay, PS out. Okay. If you run,
oh my gosh, it's working.
yeah. If you run journal-ctl -f Falco, you should see something.
I feel like you just told me to go fuck myself.
Yeah. Yeah.
No, sorry. No, that's what.
That's another way to see it.
Okay.
And you will see that Falco already is showing you some things.
Something. Yep.
Okay. Yeah, I think we're good. It's running. Okay. Is that? Do you want to run anything else? Is there anything else that's going to give me a bit more confidence? Or
we can do, like, before we dive into Kubernetes or we see anything else, I will love for us to analyze what Falco's saying. Looks like you're running Calico.
Yep.
And, Calico is totally, a good workload here because you installed it. But Falco is complaining because it's a privileged container and has been started by the image Calico node v3153. So it looks like we don't have an exclusion for Calico, right? We try to do as much exclusions as we are able to, but we don't, we don't have exclusions for all the, software that should be excluded. So if someone is listening and they want to, do a contribution, just go to our rules file in the Falco repository under the rules folder and make an exclusion for Calico. It would be very good as a first contribution. And if you want to try something just to see, what Falco can do, go to the TMF folder and create a file.
Like touch Lorenzo file in TMP.
All right. Can I ask a question first then?
Yeah.
Sure.
So that
Why are we here?
So this is visible to people. Do I have any more commands I need to broadcast, or can I close these other tabs?
Okay,
You don't have to do anything, but we probably want to configure the kubelet, the kube API servers on the machines.
All right.
Later.
I'll just grab the IP address of this node then and get a new tab.
Yeah, maybe if you want,
if
you're able. To.
Yeah, that's fine. I'll keep the splits here because we may have to do other stuff, and the rules file itself may have to show up. Okay, so let's jump on this box. Now, what we were saying there was so that this is the line here. So Falco is running. As notice, we have a privileged container, and okay.
And what else Falco is saying here is starting an internal web server, because we by default start a web server which exposes a Kube API server webhook endpoint for the audit logs. And you can configure a Kube API server to send hooks to that. But before we dive into that, I will love you to try to make Falco angry.
Yeah, let's create a Lorenzo file here. Okay, and then chmod g plus s Lorenzo. Save this file. Also empty. It's no chmod on the file.
Yeah, just chmod the file.
Set the SUID group ID g plus s.
Plus s.
Plus s Lorenzo. Okay, now if you go to the Falco output, you should see an alert triggered.
Aha.
Look, notice setVD or setGD bit is set via cmod, and it tells you everything that it knows. That the file name was TMP Lorenzo, the flags that have been set, the user that did the operation, and other things like that. The exact command line, cmod g plus s Lorenzo, and in this case, container ID is host because we are running this operation on the host, not in a container. But if you do the same, like starting a container, an Alpine one, for example, and expose a shell in the container, and you do the same thing, Falco detects it. In that case, it will give you the container ID of the container where you did that operation, that malicious operation.
Exactly.
Right.
And also shows you, before telling you that, tells you, hey, someone started a container with root shell, and they are doing commands, and the command is this one.
Yeah, let's try. Maybe it's better if we try. So,
Okay, so
Just
what do you
Docker run,
Docker.
Docker run
run.
IT Alpine.
Docker run Alpine, Docker.
Alpine 3.9.
Do dash IT.
Yeah.
Yeah, something like.
Oh, this connection is very fast. Okay, cool.
So, like you can edit a file in the bin directory, or you could redo the TMP Lorenzo thing, or you can
maybe try to create a file in the bin directory with whatever you want, and just save it, and then go out.
Just touch the file without it.
Yeah, and if you do APK like you were doing, it will also see, hey, someone spawned a package manager.
Yep.
There.
Okay, so just touching that file, and then you want me to drop out the container and look at the Falco logs again.
Yep.
Yeah,
All
I
right.
love the comments.
Red.
I love the comment I just said. I love how Leo is sat here like I want to type. Yeah, it's always like that.
Okay, so Falco internal syscall event drop. So what does this one mean? What does it mean by the one system call was dropped in last second?
That in some cases, this is something that we've really been trying to solve, and we improved a lot. Basically, as Lorenzo was saying 10 minutes before, we are using syscalls, which are the main interface that we have to the Linux kernel. And the problem is that syscalls are a lot. They change very often, so it's very hard to keep Falco on track. But also, they happens at a rate that sometimes is very, very difficult to keep up. So in some cases, for various reasons that can depend on the throughput of syscalls, the amount of syscalls that are happening on the machine, or at the same time, issues with the memory pages and things like that, we can experience and detect some drops. So we can experience that we have not received some input events on Falco, so we could not know what happened only in that exact instant. But this basically is dropping like one system calls in the last second. In a second can also happen 1 or 2 millions of syscalls. I mean, okay, we will fix it. We will try to avoid this, to bring this number down to 0. But this is what that log tells us. What we are really interested in here about the experiment that we were doing, is that line. File below a non-binary directory open for writing, touch bad actor, file bin bad actor. So it detected and look.
You can reconstruct the whole story, right? If you go, notice privilege container started as first event after web server, and then notice set it Sysdig GD bit, which is what we did before, and then notice a shell was spawned in a container, and this was the ASH shell that you spawned, and it tells you the image and the container ID, right? Then that's the drop, but then it immediately keeps up, and shows that you just created the file. So it gives you a kind of, history of what happened so that you can reconstruct the whole attack payload and see what happened during the session of the attacker.
Yep. Also, in this case, David, as we were mentioning before, we have the container ID and image name, differently from the past experiment that was telling us container ID host, because it was run on the host.
Exactly.
Okay, so the one thing that I'm kind of thinking about now, like, I haven't configured any rules. So is this the default rule then, that if we create something in a known binary directory, it's going to trigger an alert? What are some of the default rules? Can we look
Good
at that?
question. If you go to etc Falco, yes.
I love it when stuff's just intuitive. Like I just thought it's definitely going to be there. So
just xdg path. And so you have Falco YAML, where all the default Cisco rules are. You have Falco, you have Kate's audit rules YAML, where all the rules for the Kubernetes audit are. We didn't use it yet. And you have Falco rules local, where you can add your own rules without the package system to override them, or you can create, multiple files in rules default. A couple of options.
Rules.d.
Rules.d, yes. We are also working on a system to enable people to hook rules from the outside, like from distributed system, like etcd or Kubernetes, and also live reload them.
Yeah,
which is something that will go in the next features.
That is what we were working before entering this stream.
Yeah.
All right, so let me see what we have here. Okay, so this is the Falco configuration, but the default rules are this one. If I could type, so rules. YAML,
you can type YAML.
Okay, so we got.
Wait a minute. Since we are here, Falco rules. It's YAML, but basically we built a language. Let's call a language on top of the awesome YAML features. For example, you can define Falco rules using macros. So you can also define macros to later reuse them in different rules. For example, here we have some macros that are specifically being created to detect open syscalls, open read, open write. You can do the same, and we have for execve another syscalls that's usually used to run executables. You can also create lists that you can use to exclude or include a list of topics. For example, I will exclude Calico, this other CNI plugin, because I know that they are okay to run in my Kubernetes cluster. So I will create a list with all the name of the CNI plugins images and exclude them in that rule that we were talking about before. Soon we are also implementing a mechanism for exceptions in rules, but the Falco default rule set tries to cover the most common threats, the most common use cases, and since it's checked in the GitHub repo, everyone, and this is very common, can contribute to it and help us to keep it on track with new tools, new methodologies, new things, and so keeping the rules updated day by day. Anyway, if you scroll...
If you want to have like an example of what you did before, you can search for privileged, and you will see the rule that privileged,
Search for privileged container started.
Yes. Exactly. Launch privileged container. This is what triggered when you started Calico in your cluster.
Okay, so
here there's container started. There's a macro. Sorry, go.
No, I mean I was going to just guess what I think it means, but I'm more than happy for you to walk us through that. So if you want to run through the conditions, that's all good.
Yeah, this is what we were saying before. Basically, to avoid this rule to become like a flow of conditions, basically we used some macro here. Container started and container privileged is true, which is a field. In this case, this is not a macro, and not Falco privileged containers and not user privileged containers, which are two lists, which means that you can put something in the user privileged containers list to exclude that thing to trigger this rule. At the same time, you can go and look at the container started macro or at the container macro. If you search for macro :space container, you will reach the colon macro double colon. I don't remember how to call it in English. No, one, sorry. Colon space container space.
Yeah, there we go. Nope.
Leo really wants to type.
Yeah. Okay. Yeah. So as you can imagine, this macro is very simple. If container ID is not host, as we've seen with the two examples, that means we are in a container and not in the host, and so that evaluates to true. At the same time, container started checks the event type execv, and that basically we have the container image name complete.
Yeah.
Okay.
I think we have a question which I believe it's interesting. Cooled rules come from OPA tool.
Yep. Interesting question.
And it's a very interesting question. And the question is interesting because the work that I mentioned before that Leonardo and I are doing like today is explicitly to allow external implementations to load rules into Falco. What I mean, that we will have a default implementation of our rule loader that will go like on, files, Kubernetes, whatever we find that default means. But, either the Falco project or anyone can create a Falco rule loader that watches something and load rules in Falco. OPA is a very, good use case for that because, it's, what you express in OPA, and, it's very, how to say, it's very expressive, and it's also very generic. So you can express, a condition that resembles to Falco rules and then create the Falco rules and load them in Falco. All these kind of use cases are exactly why we are developing that. And I believe that at some point something like this will happen once we have this thing. If you believe that this is important for you, I would love to see you in our community calls to define maybe some more details. Because what does that mean? At some point, it's just what do the user expect, and I'm not a user of Falco, so I will just love to talk with some users about that.
Okay, just for anyone that's not familiar, OPA is Open Policy Agent, and if you want an introduction to that, I do have an episode scheduled for the 18th of November, so feel free to tune in for that one too. Okay.
Thanks for the question.
Yeah, that was a really good question. Okay, let's move on then. So we've got our Falco rules. We get all these default rules by default. They monitor things like containers being run as privileged. They monitor for binaries and knowing, privileged direct, not privileged direct, but where we keep binaries. We have Plesk stuff, SSH stuff. So it seems like you're casting a wide net here with regards to what we think could be potentially dangerous, and then giving people alerts on that information. And if I scroll to the bottom, we had 3,000 lines of YAML. So
do you want to know a very funny story about Falco rules?
I would love to.
At some point, we introduced the rules so that we can detect whether or not your cluster is mining some Bitcoins, right? Nice. At that point, to detect if we were mining Bitcoins, the only way that we had was, because, a Bitcoin miner, what does a Bitcoin miner do, right? They're all different. A very common thing that they do is that they connect to a miner pool to, exchange keys and say, yeah, I mined this, I mined that, or I need tokens. And so what we did, we created a rule that connects to miner pools to figure out their IP address, so that we can filter out the IP address for rules. And at some point, people start opening issues. So Falco is connected to miner pools. It's a miner. And Falco was not really a miner, but that was a good idea, honestly, because you can make some millions.
We were probably on an island somewhere.
Yeah.
Yeah, well, I guess
That was very cool.
Yeah, if you're working on security software that helps people alert on that stuff, it's also the best backdoor, where you could just go and mine all the crypto you want. So why not? Okay, so
we don't do that.
No, of course not. We're good people. So we have Falco running on all of these machines. We can see right away that we're getting output to our systemd log that tells us when bad things are happening. Is the next step now to hook up the Kubernetes audit log, or is there something else that you want to show off just from this setup that we have?
Before we dive into that, I would love to just say something to the audience, just for completeness, because you installed Falco in with APT in all your machines, right? And in a real production environment, what you will do is to put the Falco logs somewhere, or be able to at least see them in a way that it's not SSH in the machine. So Falco has some constructs to do that you can use. Falco can write logs to either a file, or to the syslog, or to
another program,
systemd, like you're doing, to another program. It can use it has a gRPC server where you can connect with the gRPC, with a Go, a Rust, or a Python client that are already there, so you can integrate that into your log stream pipeline. Or we have a software in the Falco security organization which is called Falco Sidekick, that for example can take the Falco logs and send them to Slack, or send them to AWS SNS, or these kind of things. So in a production environment, you will have also that piece that strings the logs somewhere, so that you can analyze them, for example, right? But that's not something that we do like in this session.
Yeah, that makes
the
sense.
documentation are very good for that.
Okay, cool.
So let's go with the audit.
Yep.
Okay.
What does that mean? Yeah. Oh, so we said that we have a Falco web server, right? The first thing that we can try to do is to actually send an event ourselves. Like, let's pretend that we are Kubernetes, right? And we want to trigger an event to Falco. I'm sending the command to you because we don't want to figure that out. Give me a second.
Yeah, sure.
Okay, so
I like the sound of your switches.
I don't know if can I send JSON in this private chat?
Yeah, sure. It'll work.
Sure. Okay, this is an event. You should just save it to, just copy the command and save it to a file.
Are we sure it has not been truncated, Laura?
Oh, maybe yes.
It has.
I can send a gist. Maybe.
Yeah, sure.
Yeah. Share a gist.
I knew. I should have done this before. Things.txt. And then this. All right, that's my gist. Great. So it's just a gist. It has two comments in a file named things.txt. And the first one creates just do them one by one because we need to. The first one is creates a file sample event.json. So what happens when the Kubernetes sends audit log is that it just hits an endpoint with some JSON, right? And like surprising, it's not YAML. So it sends this event, and the event here should trigger a Falco rule described in Kate's audit rule YAML. and you should see it in the Falco log. This is just to confirm that Falco is configured correctly and it's working to accept Falco Kubernetes audit event. Should be like that by default, but we just want to see an event before we configure Kubernetes itself to send them, so that we don't think, hey, it's Falco that's not accepting event or something like that. So then you can do the curl command sent to you.
Okay, so this is just going to send that to the Falco web server.
Yeah, this opens the sample event JSON file and just sends it to the Kate's audit and says okay. And you can now, we have to improve it. And you can now journal CTL, and it says, warning, request by anonymous users allowed, verb, create API namespaces. So this is how an audit log that triggers a rule looks like. And you could open the rule file for the Kate's audit logs and see the actual rule.
This rule one, request by anonymous user.
Exactly.
Okay. So
it's very cool because when you have a Falco logs, you can also, at some point, you can start ignoring them.
No, it's the other file, the file named Kates_audit.
Exactly. Yes.
Exactly.
So the rule says it's a Kubernetes event, and the username is system anonymous, and the authentication was allowed. And anonymous authentication should not be allowed in your clusters. And so if someone manages to do that, and this is to match the CIS benchmarks. There's a CIS benchmark 111 every time a CIS benchmark comes out or a Kubernetes CV comes out, we try to update the rules files both for Kubernetes audit and both for the syscalls to make sure that we alert on that behavior.
All right, awesome.
If we find the email for the CV.
So I'm just processing in my head. So we actually, without enabling any of the kubelet flags, we just showed that the Kubernetes stuff works, right? Like we created a Kubernetes JSON, and then we just sent it to Falco directly. And
this event, of course, didn't really happen in Kubernetes. It's just that we simulated it. We can now go and edit the Kubernetes API server flags and configure it with the audit log path, audit policy file, and audit webhook config file. And in the Falco Evolution repository, we have an audit policy that you can pass to it. That is basically how you configure Kubernetes for sending events to an endpoint. For Falco, the dynamic webhook feature that existed in Kubernetes up until 1.18 was very useful, but it got dropped. So everyone who needs to configure their Kubernetes cluster needs to do this manual step, which is something that we are working on removing, if it's even feasible for us. But every cluster is different. You might not have vanilla cluster. You might have a cluster from a distribution that doesn't do the same things in that way. So it's just just configuring the audit log. So where is your API server flags file?
Yep.
Kubernetes.
No worries. One step at a time.
Server. Container D. I did look this up, and now I'm drawing a blank. Let's see.
Oh, before you start changing it on every node, we should just also download the audit policy file.
Yeah. Go to the github.com/falcosecurity/evolution example folder evolution.
Okay.
Oh, it's like a Pokemon.
I think I've looked at this.
Yeah, go. Yeah, app. Yes. Auditing policy YAML. Okay.
Yeah, we have a
Download this file.
documentation to do this here, but we are trying to do it without looking at it.
Okay, so you want me to copy all of this?
Yeah, just download this file on all your nodes.
Vuget this file, or Vuget, as you prefer.
In a place where you feel like you can leave it there. Like, for example, I don't know, ATC Falco over...
Okay, so broadcast, wget.
Broadcast, yes. I'm broadcasting some. We are broadcasting a broadcast. Oh my gosh.
Etc. I'll just store it here.
Yeah.
Yep.
So I should have audit policy. Good.
Very good. You don't have to configure it because it's actually, set it up to do the default things, which should be good. And now we need the webhook config to pass to Kubernetes, which should also be there, but I can drop it in the gist.
This one here?
Yeah, that one.
Exactly. Yeah, we have to change Falco Service Cluster IP to localhost 127.0.0.1.
Yep.
Okay, and this is just something I'm going to apply to the cluster, right?
No, this is something that you still pass to the Kubernetes API server.
To the flags.
Okay. We need to pass to the Kubernetes API server two files: the audit policy file and the audit webhook config. And
also the audit log file.
Yeah, and also the audit log file if you want to save the logs of file too. Okay, so that's great.
Yep, that looks good. So what's next? We have to add the API server flags, right?
Exactly. Edit API server flags.
All right, so let me find it. Status.
Let's hope this Kubernetes cluster starts again after we do this.
It will. It looks like it's being controlled by...
Can you edit them via the cluster API thing that you did, or you can't? I'm not sure.
I could, but we'd have to wait for that to roll the changes out.
Yeah. Just my curiosity. I don't want to do it. I mean, I'm scared already, but...
Okay, so Kubernetes manifest kube API server. All right, okay, we got what we need here. So
that's cool. So the flags are...
So we want to do that on all of them. So let me... Kubernetes manifests a kube API server. Okay.
Yeah, so the flags that you have to add are audit log path.
I think that's I've got something.
Let me copy them in the chat, probably.
Oh yeah, sure, go for it.
I think they are in documentation too, but I mean, I hope they are.
Well, the first one should be this one: kube-api server-arg equal audit policy file, and then the other is about the webhook config file. Yeah,
just change audit policy file with etc Falco if you copied in etc Falco. I don't remember where you copied it.
I'm writing the comments in the private chat.
You've already done it for me. Perfect. Thank you, Leo.
You're welcome.
Right. Are those files there or they are in etc Falco? I don't remember.
All right.
etc. They are in etc, not etc Falco.
Okay, so we're adding two kube API server arguments. One of them is audit policy file, which goes to the YAML file we got from the Sysdig repository, the evolution repository.
No, I think, wait. This is wrong. We have to remove kube API server arg and just leave --8 audit policy file.
Right. Yes.
Yeah, of course. So --.
Yeah, exactly. Yeah, this was for K3S.
Okay, so we're adding audit policy, audit webhook config, and those go to the two YAML files. Done.
Exactly.
And then restart our
systemctl.
Daemon reload.
So these are running in the cluster because they're static manifests. So if I just run get pod-a.
Oh, nice. You really broke it?
I broke it. We have broke it.
Okay.
All right. So the static manifest, that this change would have been detected by the kubelet and then restarted them. So let's jump over to one of them and find out what is going on here. So if I...
Very cool. I know that you will have broken it.
Yeah, we have
Hey,
no API
doesn't
server.
worry.
Now let's just confirm the two paths. So we said we had a webhook.yaml.
Okay, probably.
Yeah, with path is slightly...
Yeah,
Probably
it's not
the path.
webhook config, it's webhook.
It's webhook YAML. It's only webhook YAML.
I will rename the file, honestly.
Easy fix. So...
Yeah.
And then by magic, this is going to come back any second now.
It's going to come back. Are you sure? I don't know. It's still Kubernetes. And also Falco. So...
let's restart our kubelet. All right, so something's still failing. So okay, so let's just confirm. We have webhook.yaml, and we have
Yes.
audit policy.yaml with a dash, which is audit policy.yaml. Okay, those actually
Are both YAML or YML?
good question. Too many tabs. Too many tabs. One more. Yeah. .ya. Yeah, they're okay.
And do we have any logs from the API server, like anywhere?
Yes. So var log containers. Let's get our to the Kube API server. Which one is the most recent? This one here. Okay, so audit policy.yaml does not exist.
No such file or directory, so the name is not that.
Audit.
It's the same user.
Okay, so yes, here's the challenge, right? This is a static manifest, so we need to move that file, don't we?
Maybe.
We do. So let's look at the mount points. Let's just open.
Oh, yes, because this is in the container. It's not
is.
the right. Oh, right. Very good. I love this.
I hate it. But anyway, so let's... so
Let's share...
Oh, I need to do this in everything, right? So...
Oh, it's very, very good. Now, so if the kubelet is in a container, it will not be able to just talk to Falco via 127.0.0.0.
Yep.
Also.
Shall we switch over to the backup cluster? Or, do you want or should we stick with this?
As you prefer.
I mean, you are David. I'm just worried. So.
Okay, so let me explain the problem then to the people that are watching. What's happening here is our API server is running inside of a container and not on a host. The challenge with that is these two files exist on the host file system. Now, what we can do is modify the mount points at the bottom. And if we do that, the API server will start. But then Falco still has to speak. Does Falco speak to the API server or the kubelet?
API server. But we can, I think that we can figure it out.
All right, let's do it. So let's just... I'm going to move both of these files to somewhere that is a bit more friendly. So let's call this our Falco 2. That's horrible naming. No, let's not do that. API server. And let's move our webhook and our audit file into the API server. Let's modify our static manifest now and add that as a mount point. So Kube API server, jump down the bottom. Let's add a new volume, host path, path / etc. API server, and type directory or create, and name API server config. Now we can go to volume mounts, mount path, etc. API server, read only true. And we need the name, which I called API
server config.
I love how you remember all the
All right, so that is going to make that available. Now we've got one more change to make in this file, which is those arguments. So instead of here is etc. API server, API server.
Oh, wait. And I also think that we need to change
the IP address in,
So it's advertising on the host IP, so we can just change. So we should be okay, and we can fix that anyway if we need to. What happened on these machines? We'll just ignore it. Now that's a static manifest, which has now been reapplied. I'm gonna feel brave.
Get nodes.
Yeah.
Yes.
Oh, partying all night long.
It's less nodes than before, but should be.
It's okay. No,
I was joking.
All right, so we got our API server running with our Falco and audit integrations. We can celebrate, but that's only step one. So next, can we confirm that Falco can speak to the API server?
Yeah, let's open the Falco logs in one of the nodes, and then we can try to do something evil and see what Falco thinks about that.
Yeah.
I see Kubernetes stuff.
Yeah, so
it's working.
It seems to be working. It seems. Let's now try.
Yes, it's working.
Yeah, I'm joking.
We knew it was going to work, right? We knew. It's fine.
I sent you a command. You can try to create a config map with a credential for like an AWS access key.
Okay, so I,
for example,
will jump over to here. So this is me speaking to our cluster. We're creating a config map. We're calling it AWS creds, and we're giving it something that looks like a secret, right?
Remove the backslash.
Yeah. After AWS creds. Yeah.
Yeah. Yes. So this should alert all the Falco instances at some point.
It depends on which instance are you looking the.
Okay. So if I come
Just try to get the logs again.
No, this is.
Or maybe it just went into the sea of the logs.
So where do you want me to look? Sorry.
We want to see, or maybe it's not in this rule set, the things I want to trigger.
Okay, so we can check that as well, right? So if we do Kubernetes rules, and I'm assuming if I search for secret
AWS, yes.
AWS rule. Okay, so we have a macro at least.
Same private credentials, yes.
And we do have a rule that uses the macro as a condition here.
I believe that there's some other rule that it's because the way events are triggered is that if an event triggers a rule first, you're not going to see the other. So probably the way you create things is triggering a rule first. Like maybe it's triggering some privileged user, the other rule that you're seeing, right? If you show me the logs.
Yes. Okay. So we want to look at the Falco logs again, right?
Yep.
Yes.
The cluster binding.
Yeah, there's a lot of stuff.
There's a lot. Maybe it's hidden before these ones.
Yeah, I think I want to see the UD journal CTL XAF.
Let's try.
Falco. Okay.
Let's have a look at it this way.
Error file below. There's a lot.
There's a lot. Let's see if I can
warning pods, sensitive file open, warning pod file. Yeah, there's a lot of stuff.
Let me turn off the pager. And
maybe grep for
AWS. Oh, AWS.
I didn't show up for some reason. Maybe that, I don't know.
So can I just understand what's going on here, right? Because currently I'm on the control plane node. Should all of the Falcos be alerted to this secret creation?
That's a very good question. It should not be like that because you don't have the API server on all nodes, but you have the manifest on all nodes.
So we have to go to the active master then, right?
Exactly. I thought you were in the active master.
Well, when we restarted the API server, I have no idea which one picked it up. So we need to look.
Okay, cool.
Okay, so if I take a look here, let's see if I can see the IP address.
Because they're only the masters that they create, that they send the events, right?
So this one actually potentially is the master, but what I will do is open the other two, and
you still get nodes -o wide should be useful.
Okay, get nodes O wide. Let's just grab these IPs.
Or maybe it doesn't work, right?
It does work. I know it works. We just need to find the correct API server. Now that I know how it's working, I'm confident we can get the logs. Okay. So
you can insert your password with your fingerprint.
Yeah, SE key is fantastic. Or if you're on Linux, there's a similar one too. But I have to use Mac at my new role, which I'm hoping changes soon. Well, there we go.
Yeah. I knew it worked. I mean, I didn't dream it.
I mean, we tried this like 10 hours ago, so nothing changed in Falco in the past 10 hours. So,
all right, that was
one good improvement to Falco that we could do is we don't print out the credential in the logs.
Yeah, I mean, otherwise this is very useful.
But this is a rule change, it's not a software change. Like the person that made the rule explicitly decided to print out the credential. So it's not. So maybe we can make a logger change that if we find a credential, we just hide it, but it's a bit more complicated than that.
Okay, so that was really cool. I'm going to try and summarize this, right? So we modified the API server on our control plane with two flags, audit policy and audit webhook. We injected some pre-canned config that we got from the Falco repository, this evolution repository here.
Yep.
So we just copy and pasted that. We didn't really do anything else except change the Falco IP just to be localhost. And by that, we get all of the Kubernetes events going to Falco where the rules kicked in, detected a private C, and logged that. Now, we had a bit of trouble finding that, but normally in a production scenario, that would be getting centralized anywhere. I'd see that in Elasticsearch. I'd see that in Splunk. I'd see that wherever I'm storing all my logs, and it would be visible front and center. That's awesome.
Exactly. So, yeah, in a normal production scenario or in a development, because in a development machine, you only have one Kubernetes node. In a production scenario, you have the centralized logging. So when you do this kind of demos, you never remember that kind of details. But
yeah, I should have spun up a single master control plane. I probably went a little bit over the top with my HA setup. But
just a little bit.
It's very cool to see how you over-engineered this demo.
Yeah, you should see how many cores I've got on this thing and how much RAM as well for a cluster I'm spinning up for an hour. But that's the joy of bare metal. Like, it's great how much power I can throw at this.
Anyways, David, since you mentioned the evolution repository, I think could be useful for the audience and people interested in Falco to know that this repo evolution is a simple repo where we basically try to keep all the things, the getting started guides for users. For example, you can find here examples, manifest for deploying your first Falco in your Kubernetes. There were also Helm charts here. Then later we will bring in the charts repository. Various examples, third-party integrations, things like that can be very useful for people that loves to approach a new project just by trying it, without having to study all the moving pieces of Falco.
Without a PhD in a BPF. before.
All right, so I'll add that to the show notes. This repository is definitely worth checking out then for anyone that is going to start playing with Falco. Excellent. Is there anything else you want to show off, cover, anything like that before we finish up for this afternoon? Is there anything that we've not covered that makes sense?
Oh, yeah, that's the thing. Go to Falco Security/pdig.
Yep, and there's also eBPF if we want to, because we run Falco now with the kernel model, not with eBPF probe.
Okay,
Yeah,
so
maybe we don't want to restart Falco to run with the BPF now, right?
So, sorry, what should I go to here?
I just want maybe to talk for 10 seconds about our user space efforts for with the pdig repo.
Search for pdig.
Or pdig. Thank you.
Yep.
Yeah, pdig.
Pretty
Yeah,
tasty.
So just a very underrepresented repository in our community. But
For now,
yes. So we told about the fact that we, either run with a kernel module or a BPF probe, right? And that's a very good thing, to have, because, you can start kernel module, you can use an BPF probe, but that doesn't work in every environment.
yeah.
For example, it works very good on bare metal, but it doesn't work on sandboxed environments. For example, if you put that, on a Fargate environment or something like that, the only one that came in mind. Or you put that on a gvisor or on something like that. So you need something that doesn't rely on,
the possibility to assess the kernel.
Yeah. And so we started working on an interface, which is the Userspace API, which is not very well documented yet because it's just a ring buffer in memory that's shared between processes. But that one allows us to send input events to Falco. And one implementation of that is pdig. So pdig just uses ptrace to send events to Falco. It's not as performant as Falco, as the Falco kernel module is not as performant as the eBPF probe, but it's a way to show that Falco can accept different kind of events coming from different sources that are not just, those two that we are deploying in production right now. And also this open, a world of possibility for different kind of devices, like, you want to deploy Falco on macOS or Windows, something like that. You have an interface. And you can
Also to different kind of inputs. Maybe you could. Our goal here is to create in the future. We are working on it, an interface so that the community can create, for example, another inputs for Falco that this time is not Kubernetes audit logs, but some other kind of audit logs without naming names. I don't know, but just or other kind of events, whatever. And so in that way, user then will be able to write rules to detect some events and trigger alerts on some events depending on this new input.
I found this useful when I was trying to make Falco work on Arch64. I was using Equinix for starting a very beefy machine because, I had I didn't really have a Raspberry Pi. I didn't want to wait for it to compile Falco because it already takes a lot of time. Like we compile OpenSSL and other things. So it takes a lot of time. And I didn't want to wait. So I just started that machine. But then I didn't have a driver because our kind of modular BPF probe are not made for Arch64. They're made for x86. We ported that to Arch64 now. But when I wanted to just, see, hey, this thing works, I can just use pdig because it's not, I can just use the user space interface because it's not architecture dependent. And, that worked out very well. So also for, porting to new architectures.
Nice.
That's it. This is a very cool improvement that we did over the last year. Thanks to the whole team and overall to Loris, which actually made the code happen.
Awesome. That's cool. It's good that people have that choice then, depending on the environment that they're running. They've still got an option to instrument and understand their applications using Falco. That's awesome. Nice one. So we have a couple more comments. Our mutual friend, Gianluca, says ciao.
Hi.
And we got a question from Akakorin. Is there a GUI? I mean, I'm happy to give you what I think the answer is, and then you two can correct me if you wish.
Yeah, please.
I'm going to assume there's no GUI. From what I understand of what you explained to me today about Falco is that it's a detection system that emits events, and we should be storing those events somewhere where we have the ability to query them and notify on them and alert on them. And that may be something like Elasticsearch, InfluxDB, or even just syslog. But from there would be the interface. Is that correct?
Exactly.
Yeah, the answer is correct. There's a GUI which is commercial, which is developed by Sysdig, but it's not, Falco. It's, a product of Sysdig, which is called Sysdig Secure, which also has a GUI for Falco, but is just, it's one of their additional values on top of Falco.
I want to be clear with the audience here. Sysdig pays us a salary. I don't know why, honestly, but Falco is a CNCF incubated project that plans to graduate next year and has been donated to the CNCF. Maybe we missed a bit of history of Falco, so let me just be brief about it. But Falco is graduated, was sandboxed in 2018, was initially started at Falco in 2016 as an open source project, but after that, it has been donated to CNCF. Basically, we are CNCF maintainers, which means that Sysdig engineering in any way can interfere with the plans that we have with Falco, which is, by the way, something that I love because it means that I can do whatever the hell I want. So yes, there's a commercial GUI. Probably there are also other commercial GUIs, and there will be out there. But this is not a problem for the Falco maintainers or for the Falco community, because our goal is to make Falco consumable by the cloud native community, and this is the reason that we are working on APIs for rules that watches rules that can changes, APIs for user space inputs and things like that to make it more integrated with the whole cloud native ecosystem. That's the goal.
Sweet. So to summarize that again, you should be responsible for storing the events wherever you want and visualizing them that way. But if you want to support further development of Sysdig and their time to work on this continually, and you're happy to pay, you should look into Sysdig Secure, which does it all for you. That sounds awesome. And of course,
or you can pay someone else that does the same thing, but it's just because Sysdig made a product out of it.
All right. Well, I just want to say thank you to both of you. This has been a very great learning experience for me. Even though we had a couple of small challenges, we overcome it. We've seen Falco running on our bare Linux system inside of our Kubernetes cluster. We saw those events. They're going to help me provide secure platforms for my Kubernetes stuff. So that's awesome. Thank you again for joining me.
Thanks, David.
Any closing thoughts before we say goodbye?
Yeah, I love your setup, David, and your music.
Me too. I also have another thought. Don't we have 5 minutes to try BPF driver? I'm joking.
I don't think we do.
I'm just joking.
We can always have another session. Don't worry. We can come back anytime you want and look at more stuff here.
We can have a session on debugging why the BPF driver doesn't work on kernel 5.9
with Clang 10 or things like that. Okay, let's do it.
Do you have GDP on your Mac installed and everything? We figure it out.
Not today. All right. Thanks again. Have an absolute great day, and I'll speak to you both.
Thanks for inviting us.
Thanks for hosting us.
Cheers. Bye-bye.
Ciao.
Bye-bye.